Hello teacher, this is my short video about learning algebra, and my application is cryptography based on Hill Cipher method. About introduction, uh, is a member with one member, and my name is Phạm Trung. I'm responsible for coding and producing video. My ID is 2252858, and about the procedure. First is theory about the cryptography is a method that was produced by Mr. Hill, published a scheme using some available ideas as well as some linear algebra. Suppose that we decide to encode numbers 2 at a time rather than 1, and if x and y are two-digit numbers, each is representing a letter or space as before, and one constructs the 2 by 1 column, and D is for decoder. Then we take a 2 by 2 matrix, which is the encoded matrix. Where entries are from the set modulo 26, and from the product A times D will be equals to E. To that will recover that will record in the encoded message. To recover to the original message, we will simply compute by take the inverse matrix is A by -1 times E. About mathematical tool, I will use Python with NumPy library to calculate the transpose matrix, inverse matrix, and matrix multiplication. This is how I do it. First, we will input a raw message. That will be a word or something. I will try linear. Here. So we will input a raw message and then create a 2 by 2 invertible matrix key. About first encode step. So we will build the matrix with 2 columns according to Hill Cipher method. We 12 in Z model 26, so L will be 12, I will be 9, N will be 14, E will be 5, A will be 1, and R will be 18. So we will change both matrix to multiply easier, like this. Then we will multiply the matrix key with the changeable matrix here. So we will have a multiply matrix and changeable matrix here. So you will ask how can we convert it into the encoded message. So we will take the modulo 26 like this. We will associate all 2-digit integers with characters A to Z. So we will use modulo 26. So with a number which greater than 26, so we will take modulo 26, like 30 modulo 26 will be 4 here. 114 modulo 26 will be 10. 24 is smaller than 26, so it will be the same. one root will be 22, 27 will be 11, and 113 will be 9. So we will have the encoded message, which is DJXVKI. Next, we will have the decoded steps. So we will take the inverse matrix for decoding, like this formula here. So it will be the matrix key we will have here. Next, we will multiply the inverse matrix with the encoded matrix, which is here. And finally, we will have the original message, which is linear. Thank you for listening.